Students, you are very much familiar with candle. It is solid in state, right? But on burning candle, you will see some sort of liquid near the flame, right? As you can see here, burning candle, it is at the base, you can see it is solid in state, right? But around it, you can see that some sort of liquid. Candle is in liquid state. When I tilt this, then you can see some liquids are falling down, right? How does the solid changes into liquid? You are also much familiar with this object. What is this? Do you know this? This is naphthalene ball, mostly used in clothes to repel insects and all, right? When this naphthalene ball is left for some days, then the naphthalene ball will disappear. Have you ever wondered about this? And here you see a beaker containing some quantity of water. What will happen if this beaker is kept inside the refrigerator for 10 or 15 minutes? Let us see. So, after keeping the beaker inside the refrigerator for 15 minutes, I have got this. Here you can see that the water becomes solid in nature. It becomes ice, right? Earlier it was liquid, but here after keeping it inside the refrigerator, we have got solid substance. So, we have seen that the candle which is in solid state becomes liquid when it is burnt. We have also seen naphthalene ball disappears in air. The water which exists in liquid state becomes solid when it is kept inside the refrigerator. What could be the reason behind all this? This is Science Capsule, a perfect self-learning tool for school children going to explain the science behind all these experiences in detail. So, watch till the end of this video. This video is going to be very interesting and innovative. If not subscribe this channel and press bell icon so that you will be notified whenever I upload a new video. Let us start today's session. Dear students, in the experiences what we have seen in the beginning of the video, we could see some change in state. We are much familiar with the states of matter, right? A detailed video has already uploaded in this video. If you have not watched that video, then you will find it in the I button and I will also provide in the description box. So, we know that the arrangement of particles in solid, liquid and gas. If you have these ideas, then it will be very easy for us to understand how the matter change its state from solid to liquid, liquid to gas in reverse order, gas to liquid, liquid to gas. Now, here there are two important factors on which the change in state of matter depends. One is temperature and another one is pressure. Before going to understand the change of state, we must know the arrangement of particles in solid, liquid and gases. If you see the arrangement of particles in solid, liquid and gases, then the particles are very closely and tightly held in case of solid. Whereas in liquid, the distance between the particles are little more, and in gases, the particles are very far away from each other. From this, we can say that the intermolecular space is very less in case of solid, whereas in case of gases you see lot of intermolecular spaces are available. So, whenever we talk about solid, then the particles must be very tightly arranged. In case of liquid, the particles will little far away from each other, whereas in case of gases, the particles lie very far away from each other. While learning the arrangement of particles in these three states, one of the important term to be remembered is kinetic energy, which is very important to understand the change of state from one, which is very important term to understand about change in state, that is from solid to liquid, liquid to gas or in reverse order. So, kinetic energy will be very less in case of solid and very large in case of gases. So, having this idea, let us understand how change in state takes place with the help of temperature and pressure. So, you are much clear about the arrangement of particles in solid, liquid and gases, right? What will happen if the temperature is increased or decreased to the particles of this matter? About that we will see. Students, solid can change into liquid, liquid can change into gases, and in reverse order gas can change into liquid and liquid can further change into solid on the basis of temperature and pressure. let us see what happens when temperature is increased or decreased. Dear students, you should know that when temperature is increased, then its kinetic energy will also increase. So, kinetic energy is the energy possessed by the particles of the matter while they are in motion. More the motion, more will be the kinetic energy. Just before we have seen that the particles are restricted to move in solid, whereas in gases they are very free to move in the matter. So, on the basis of kinetic energy, we can easily understand the movement of particles in these three states. Let us take an example of candle on heating. It becomes liquid, which we have seen in the beginning of this video, right? In the candle, the arrangement of particles will be like this. Here the particles are very closely held. Now we are increasing the temperature. On increasing temperature, what happens? The particles gain energy. As a result of this, the kinetic energy possessed by the particles will increase. When the particles gain temperature, with that its kinetic energy increases. When the energy gets increased in the particles, then they push the particles to one another. In such case, what happens? Each particles in a solid matter, that is in case of candle, they get enough energy and they push other particles nearby. Gradually the particles get pushed and they get some space. Somehow they manage to get some spaces around them. When the particles attain certain spaces which corresponds to the arrangement of particles in liquid, then the solid changes into liquid. Got it, children? Let us understand the second experience, that is naphthalene ball. When naphthalene ball is exposed in air, they disappear, right? Naphthalene is initially solid in state. If it is solid, then the arrangement of particles will be like this. Here naphthalene ball is not heated. Even though it is not heated, it disappears in air. Here what happens? The naphthalene ball gains temperature from the surrounding. This temperature increases the kinetic energy. When the kinetic energy is increased in the particles of naphthalene ball, then they push the surrounding particles. As a result of this, the particles get some more spaces. If the spaces available between the particles corresponds to the intermolecular space of liquid, then it will become liquid. But in case of naphthalene, it does not change into liquid, it directly changes into solid to gas. Dear students, there are certain substances which can directly change from solid to gas without undergoing liquid state. This process is known as sublimation. Here, when the particles gain temperature from the surrounding, then the temperature increases the kinetic energy of the particles of naphthalene ball. As a result of this, the particles push the surrounding particles in such a way that the intermolecular space corresponds to the arrangement of particles of gas. Naphthalene ball changes into gas. So we see naphthalene ball disappears in air. Since gases cannot be seen, so we say that the naphthalene ball disappears in air. Not only naphthalene ball, other examples which undergo sublimation, which directly changes from solid to gas, is camphor, which you use in your home. These are the examples which undergo sublimation, which changes directly from solid to gas without undergoing liquid state. Now we see the third example, that is water. We have taken a water in a beaker and kept it for freezing in the refrigerator. Finally we got ice. Water is in liquid and ice is in solid. Now take this example to understand. We know that arrangement of particles in water is little far away from each other. While keeping it in the refrigerator, what happens? The temperature of the system gets reduced. Here in this case, the particles lose energy. Now the particles are little far away from each other. This is because they have enough kinetic energy to move in its own position or little freely in its matter. But when the temperature is decreased, in the earlier case we have seen that on increasing temperature, kinetic energy will increase. Similarly, on decreasing temperature, kinetic energy will be decreased. When the kinetic energy of the system gets decreased, then the particles will not have enough kinetic energy to move freely in the matter. The particles are compelled to come closer to one another. While further decreasing the temperature, continuously the kinetic energy of the particles of liquid gets decreased. The particles come further closer to each other. Finally, when the particles come more closer which corresponds to the arrangement of particles in solid, then water changes into ice, that is solid state. Got it, children? This way, on increasing temperature, solid can be changed into liquid. On further increasing the temperature, liquid changes into gas. On decreasing temperature, gas can be changed into liquid. On further decreasing the temperature, liquid can be changed into solid. Got it, children? Dear students, by applying pressure also we can change the state of matter. We know that gas is highly compressible, which means pressure can be applied on gas. Let us understand separately. Suppose this is the matter, that is gas. Here are the particles. Here we take it as a piston here. On applying pressure, the particles will come closer and closer, right? Since the space available for the particles of gases will be reduced on applying pressure. When we increase the pressure continuously, then what happens? The particles will come closer and closer to one another. Finally, a stage will reach in which the arrangement of particles correspond to the arrangement of particles in liquid. In that case, gas will be converted into liquid. So, this way, by increasing pressure, gas can be converted into liquid, liquid can be converted into solid. Now, we see what happens if the pressure is decreased. If you release the pressure, then what happens? The particles will freely move. If it moves freely, then space will be created. If the space corresponds to the intermolecular space of liquid, then solid changes into liquid. So, on decreasing pressure, solid changes into liquid. Likewise, on further decreasing the pressure, the particles would move freely and more space will be created, right, due to less pressure. And finally, the intermolecular space will be so large that the intermolecular space corresponds to that of gas. In such case, the liquid changes into gas. This way, on increasing pressure, gas can be converted into liquid, liquid can be converted into solid. On decreasing pressure, solid can be changed into liquid, and then liquid can be changed into gas. So, dear students, that's all in this video. If you found this video useful, then hit the like button. If you have any doubt, then you can mention it under the comment section. If not subscribe this channel and press bell icon so that you will be notified whenever I upload a new video. See you all another day. Till then, keep learning, take good care of yourself. Bye.